This is Joe narrating a PowerPoint in Science in the unit on physical science. It's lesson 3 concerning chemical reactions. This is found on page 546 in the Kaplan book. We'll learn the following new terms: chemical reactions, where you have reactants combining or breaking down to form products. We'll learn the conservation of mass law. We'll learn about chemical equations and how to balance them. We will learn the difference between endothermic and exothermic reactions. And we'll learn about activation energy, which is the energy that gets the reaction going. For example, a common chemical reaction is when you turn the burners on your gas stove. Natural gas is methane. That methane comes out of the gas burners, combines with oxygen in the air to form carbon dioxide and water. This reaction gives off heat, and it is called an exothermic reaction because it does give off heat. You need a little bit of activation energy in the form of a spark to get this reaction going once you turn the burners on. The chemical reaction itself can be described by a chemical equation. Here's a chemical equation for the combustion of methane. You have CH4 on the left combining with two oxygen molecules. Those two are called the reactants, and they combine to form carbon dioxide and two molecules of water. Those two are called the products of the reaction. So this is a different form. They're showing the molecules in model form. You have a carbon combines with four hydrogens on the far left with chemical bonds to form the molecule of methane. This one molecule of methane combines with two molecules of oxygen in the air to give off carbon dioxide and two molecules of water. The law of conservation of mass says that matter cannot be created or destroyed. It just changes in form or in combinations. So for example, the total weight of methane and oxygen on the left equals the total weight of carbon dioxide and water on the right. And that makes sense because if you add up the number of carbons on the left, you have 1. The number of carbons on the right is 1. In methane, there are 4 hydrogen atoms. That is the total number of hydrogen atoms on the left. And on the right, there are also 4 hydrogen atoms. There are 2 molecules of water. Each molecule of water contains 2 hydrogen atoms for a total count of 4 hydrogen atoms on the right. Likewise for oxygen, there are 4 oxygen atoms on the left, and there are 4 oxygen atoms on the right. 2 oxygen atoms in the one molecule of carbon dioxide, and 2 total oxygens in the 2 molecules of water on the right. When you balance chemical equations, you can change the coefficient in front of a chemical formula, but you cannot change the number of atoms in a molecule. The numbers on the lower right, called the subscripts on each chemical formula, cannot be changed. So again, here's a balanced chemical equation. You have the reactants on the left, produce the products on the right. There are the same number of carbons, hydrogens, and oxygens on each side of the balanced equation. On the GED, you might be asked to fill in a blank to complete or balance a chemical equation. If you look at this chemical equation, the combination of hydrogen with oxygen to form water, you see that there are 2 oxygens on the left and there are 2 oxygens on the right. There are 4 hydrogens on the right, so there must be 4 hydrogens on the left. Since each hydrogen molecule contains 2 hydrogen atoms, there must be 2 hydrogen molecules on the left, and you would write in 2 in the blank. Now you have a balanced chemical equation. This is a diagram showing an endothermic reaction. This is a reaction that absorbs energy from the environment. So the reaction is proceeding from left to right. The amount of energy being absorbed in the chemical process is on the y-axis. In this reaction, the reactants have a lower energy than the products because the products have absorbed energy from the environment. This type of reaction occurs, as your book says, when you cook an egg. The egg is in a liquid state. You cook it, it changes its chemistry to produce a solid state, and the egg has to absorb energy in the form of heat for that to happen. An exothermic reaction is when the reactants give off energy in the change to the products. Usually this energy is given off in the form of heat or light. For example, the burning of methane on your gas stove gives off both heat and light, and that is an exothermic reaction. Some reactions won't happen unless you supply some initial activation energy. For example, the natural gas on your stove won't start reacting with the oxygen in the air until you supply a little spark to get the reaction going. That spark supplies the activation energy. So the reactants receive the activation energy, which gives the whole process a little higher potential energy, and then the energy is given off in the conversion to the products as a possibly substantial amount of heat energy and light energy. If we have time, you can look at those two YouTube videos. The first one shows a hydrogen balloon floating in air. If you touch a match to this, the hydrogen will react with the oxygen after the activation energy of the match to explode. A thermite reaction is a very dramatic reaction where two metals combine after receiving the activation energy from a magnesium strip. That's it for Lesson 3 in Physical Science.